Dare to Dream Different Micro Framework Contest. Advanced RC Controller featuring tilt control, which uses the accelerometer on the Tahoe development board, incorporates dual controls for a trainer override, i.e. right hand seat co-pilot that can instantaneously override any pilot actions. But the main feature includes the ability to record and play back a series of control actions. These actions are stored in 3 different track profiles that are stored persistently in Flash and can be played back on command. The user interface for this feature consists of a series of micro framework controls that are modeled after a standard VCR. This gives the user a familiar, interactive experience. Okay, this is the electronics for the advanced RC controller. Here we have the connector that routes the joystick signals from the hand controller. They come in through here, through an op-amp buffer, and into an analog devices 4-channel 12-bit A to D converter. That's AD 7993. It uses a I2C interface, and 2 of the channels from the left and right, front and back from the hand controller come in here. I also have the trainer override joystick here, and that uses 2 additional channels of the 4 channels, and again they're routed into the A to D converter, where the signals are digitized and brought back into the Tahoe board. For output, signals are driven back out and to a 2-channel MCP 4922 12-bit DAC, and that's a microchip part. Again, 2 channels, and they're driven through some more buffers and then back out to the hand controller RF electronics. Here we have a bypass switch to bypass all the electronics for testing mode, dual interactive, and 3 track profiles, recordable track profiles. Track profile 1. VCR controls. Stop, record, rewind, pause, play, fast forward. Record. Recording. Timer value turns red. Left, 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 right, forward, reverse.
Daddy, can you...
Stop. Rewind. Play. left, 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 right,
Yes,
forward.
Carson. What? All right, we'll put him down over there.
Trainer mode. Override. Trainer takes over. Pilot. Co-pilot. Pilot. Co-pilot. Record. Ready to go. Playback. Tilt mode control. Left. Right. Back. Forward. The software is constructed leveraging off of the Fusionware driver templates. I'm using the I2C and the SPI. The A to D converter and the accelerometer use the I2C, and the D to A, the 12-bit D to A converter uses the SPI driver. There is a high priority sampler thread that runs in the background and periodically calls the A to D and D to A sample provider and stores off the return values into a large sample array. Again, here are the VCR controls in operation and an underlying VCR state machine. The controls are constructed using bitmaps, and when pressed throw an event which is interpreted by the state machine. Prompting actions like rewind, record, play, etc. Rewind and fast forward operations are equivalent to seek operations on the sample array, and record is equivalent to an indexed write to the sample array. Play, of course, is equivalent to a read operation, indexed and incremented by a 100 millisecond timer. The user interface is a sliding menu of animated icons, a series of stacked panels, and status controls which are updated by their base dispatch timer. These features and controls are built up using the included managed components of the micro framework. They are very easy to use and easy to modify. Thank you for listening.